The empirical rule is featured in this video. It has a special time that it can be applied. That would be if you have a bell-shaped distribution or symmetric, as we've talked about in the past. Okay, so empirical rule is our new friend. It has some special percentages based on how many deviations you are from the mean. First value, 68%. is within plus minus 1 deviation of the mean. 95% within 2 deviations of the mean. 99.7% within 3 standard deviations of the mean. My best advice to you when solving empirical rule type questions or bell-shaped questions is to create a number line based on your standard deviation and the mean. All right, some examples for you. Adult IQ scores have a bell-shaped distribution. There it is. Bell-shaped distribution means the empirical rule applies. All right, in this case, we have a mean of 100 and a standard deviation of 15. Use the empirical rule to find the percentage of adults with IQ scores between 55 and 145. Okay, so I simply do this. I just say, all right, let's sketch out a quick number line. Start in the middle with your mean, which they said in this case is 100. Then use your standard deviation to count 3 deviations to the right and 3 deviations to the left. So in this case, 15. So if I add 15 once, there's 1 deviation. Add again, we're to 130, 2 deviations. And then we're at 145. That's 3 deviations to the right of the mean. Subtracting to the left, we're at 85. So 1 deviation to the left. Then we're at 70. So 2 deviations to the left. And then 55. We are 3 deviations to the left. All right, now identify what they want to know from the question. Okay, so they want to know what percent between 55 and 145. Okay, so find those values, 55 and 145. Okay, so here I found 145. Here I found 55. Okay, so where are we? Well, from here to here, we are plus and minus 3 deviations from the mean. So in looking at our rule, if we are 3 deviations from the mean, it means that plus minus 3 deviations from the mean means 99.7% of the data lies between those 2 places. And you're done. Okay? All right, let's try again. A typing competency test yields test scores with, and part of your question got cut off there, didn't it? Isn't that interesting? All right, I got to fill that in for you then. Competency test yields scores with a mean of 80. So you should have this on your guided notes. And a standard deviation of 10. And a histogram shows that the distribution of scores is roughly bell-shaped. All right, so we have to know that, or none of this rules apply. We can't do anything with it. Okay, so again, let's start with a little number line. Okay, so it doesn't have to be fancy. Okay, so 80 is the mean, and we're going to add 10 3 times. So we'll go 90, 100, 110. So that's 1 deviation, 2 deviations, 3 deviations. Then we're going to subtract back here to the left 3 times. So we'll go 70, 60, 50. So 1 to the left, 2 deviations left, 3 deviations to the left. Okay, so what's our question want to know? Percentage from 70 to 90. All right, so 70 is here. 90 is here. So from there to there, we have 1 deviation. So we're plus minus 1 deviation. That means we are 68% of the data within that first zone. Okay. Next, what percent of the data should fall within 20 points of the mean? All right, so 20 points would be 20 to the right puts you at 100. 20 to the left puts you at 60. So we're from here to here. And if you look, we're 2 deviations from the mean, left and right. So 2 deviations up here above says 95% of the data. And lastly, it wants to know about 99.7% of the data should fall between what 2 values. All right, so this time we're saying 99.7. That means 3 deviations. So I want to go out here to the third spot. Play with the highlighter again. So 3 deviations left and right. Then what is the range? So the value there is 110. The lower is 50. So we would just say it is from 50 to 110. Okay? All right, so again, best advice when we're dealing with this sort of problem with empirical rules, get yourself a quick number line. Then it's a lot simpler to go between the deviations and figure out your percentages. All right, so a couple examples here at the very bottom where it says problems, and again, these should be on your guided notes as well. So it says, to what kind of data sets can the empirical rule be applied? And I think I'm hearing you answer. It has to be bell-shaped. Okay, some of you may say symmetric, and that's fine too. All right, question. The output from a computer program indicates the mean is 1500 and the standard deviation is 300 for the data set. What can be said about the number of measurements between? Okay, so perfect setup again. Get your pencil, make yourself a little quick number line. Put the mean in the middle, 1500. Okay, we know that's coming from right here. The standard deviation is 300. So we're going to do 300 to the right 3 times. So that should drop us in here at 1800, 2100, and 2400. So I'm just adding the standard deviation 3 times. So I go 1, 2, 3 deviations to the right. Okay, going to do the same thing back to the left. Only we're going to subtract this time. So 3 times. So 1200, subtract 300 again. So that's 900, subtract again, 600. So we're 1 deviation, 2 deviations, 3 deviations to the right. And those are S's when I'm saying deviations. They're not 5s. Okay, so the question asks, what percent is from 900 to 2100? Okay, so 900 to 2100. Okay, we're within plus minus 2. So plus minus 2 deviation says 95%. Okay, next is from 600 to 2400. Okay, well, looking there on your number line, that's plus minus 3 deviations. So plus minus 3 deviations means 99.7%. Okay. And then lastly, they're zooming in here to 1200 to 1800. Here's 12. Here's 18. That's 1 deviation left and right. So we have 1 deviation. So that's 68%. Okay. So again, this is the empirical rule. That's what's enabling all of this stuff to happen. Okay, I'm just not making these things up. All right, the very last problem here at the bottom wants you to load this data in your calculator and then compute the mean and the standard deviation. Okay, if you want to pause your video at this point in time, you are welcome to do that. Then they want you to create a number line, plot your data, and then look at what the percents, or count the number of measurements so we can get the percents in these different zones within 1, 2, and 3 deviations. Okay, so again, if you want to pause and do that, okay, go for it. I have my data in. I have used one of our stats to calculate my mean, which I found to be 8.24. So I'm going to just say 8.2. In standard deviation, I used S sub x for a sample, and I used 1.8. Okay, so in creating a quick number line below here, I'm going to start with my mean at 1.8. I'm going to do 3 deviations to the right, 3 deviations to the left, and then I'm going to plot my data. Okay, so going to the right, my values are 10, 11.8, and 13.6. Back to the left, I'm at 6.4, 4.6, and then 2.8. Okay, so again, I'm just adding and subtracting my standard deviation that I calculated from the calculator. Okay, so then I sorted my data so that I can actually see the data from small to large, so I can plot values in the appropriate compartment. So from 4.6 to 6.4, I have, let's see here, a 5, and then some 6s, like 3 of them. In the next compartment, I have 1, 2, 3, 4, 5, 6, 7 7s. 5, 6, 7. And I have 3 8s. Okay, and then if I plot the next compartment, I have some 9s. 4 of them. I have 4 10s, so they're right here on the border. I have 2 11s, and then I have a 12. Okay, so again, I just sorted my data and then I'm plotting them in the appropriate compartment based on the number line created by the mean and the standard deviation. Okay, so we need to respond to what is the percentage of values within 1 deviation of the mean, within 2 deviations of the mean, and finally within 3. Okay, so with this data set, they even told us here there's 25 measurements, so we should have 25 data points accounted for. Okay, so each of these will be out of 25 total numbers. Okay, so let's start here with our 1 deviation of the mean, so within plus minus 1. And this is kind of a good example because we have some numbers right on the border. So we'll say if it's on the border, then count it in. Okay, so if you're on the line, you're in. So let's count here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So we have 18 values out of 25. So if you divide that, turn it into a percentage, we're at 72%. All right, so then within 2 deviations of the mean, so we're going to go from here back into here. We were at 18, so 19, 20, 21, 22. 23, 24 out of 25. So within 2 deviations of the mean, we have 96%. And then finally, if we go clear out 3 deviations, sure enough, we have all data accounted for. Okay, and will that always happen? You're probably wondering, because if you've watched the previous couple videos, we've had this same situation that within 3 deviations in an experiment, we seem to get all the data points. It doesn't have to, but it could be pretty likely. Okay, if you're comparing what we just came up with, and I just put this in beside, according to the theory of a bell-shaped distribution, our empirical rule states that 68% of the data can be expected within 1 deviation. We had 72. Within 2 deviations, again, 95%. We had 96, so a little higher. And then within 3, we expect 99.7% of the data. We were at 100. So in our experiment, claiming that it's bell-shaped, it sure seems to make sense. The numbers are pretty much in line. Okay, so thank you again. These were some notes about your empirical rule. Have a great day.